Okay, so this is my project on survey control analysis. I first thought when I started this I was going to do a control network, but the more I got into it, the more I realized it was more of an analysis of our data rather than a control network. So what made me think about it is that here at SK Nelson we have a large amount of data. And so it was really easy for me to use all this data to put into a project and kind of figure out what all this data means to us as a survey department and as a company. And we've got all sorts of point data, line data, land data, and GIS data, which is kind of new to the survey world, but it has a lot of data. So we've got point data in the form of, we've got field points, office points, we've got line data, which is roads, boundary lines, contours, land data, which is location, ownership, characteristics, and the new most large data that we've got, which has global references and data analysis with the GIS data. So point data is going to be the building blocks of all the kind of data that we've got here. For instance, we've got the line data, which the points connect the lines. So we've got to have these points to make the line data. Land data, these points, the land data describes what these points actually are. And GIS data, which attributes tons of information in these little bitty points. So a control network really got me thinking when I started looking at our traverse points and our monuments, what exactly the relationship is between the two. And I thought I would make a kind of funny little point. What came first, the traverse point or the monument point? Sort of like, what came first, the chicken or the egg? Because they've got such a symbiotic relationship. Do the monuments come first? Do the traverse points come first? It's really kind of, job by job basis. But when you look at these points, you really realize that the monuments have an equal probability of being anywhere. But the traverse points, not so much. Traverse points are usually based on where the monuments are. You want to base these traverse points where you're going to be setting up so you can see these monument points. So they really do, the traverse points really do have more of a secondary effect because of the monuments. The monuments are going to kind of dictate where these traverse points are, which I thought it was very interesting because we use traverse points as a control network, but who exactly is controlling who here? I think the monuments really are controlling the traverse points. So, the data. I took all our data from April to November and I compiled it. And I put it into two groups, our traverse points and our monument points. So this is kind of what I got when I visualized both of them. I think you can see, I really thought we would have more points in Llano and in land passes, but these were the usable points that I took out of all of our jobs. And I think you can kind of see that most of them are in Burnett County. And they're kind of equally spaced. But if we kind of zoom in, we can see that most of them are actually around Burnett. We've got a little bit in Marble Falls and Horseshoe Bay, and you can see we've got some kind of close to the river and the lake. So, with these points, we're going to start looking at the patterns and processes that made these points kind of where they are and what it kind of means to us. So I took these points and I did a series of calculations on the points. We're going to do a point density and kind of see where are most of our points for control and most of our monument points. We're going to do a mean center and kind of see what the average is of all of our points. And we're also going to do a directional distribution, kind of see which way these points are kind of going. I found that one the most interesting. So you can see where most of our control, the density is in Vernon. I kind of zoomed in on that because that was the most dense point. And you can kind of see with the control laid on top of it that that's pretty true. So for the mean center, it's the purple, and that's really close to Vernon as well. So most of these are kind of centered around Vernon. And it's our control direction. So that's kind of the direction that our traverse points are kind of in. So where are all the monuments? The monuments are situated, we've got, little pockets around Burnett as well. So we kind of see a theme here that most of our stuff is around Burnett. And if you can see kind of in that little corner up there, that's going to be the Threadgill. So for some reason I didn't extract any traverse points out of it, but I did pull the monuments. So I don't know where the traverse points are. The monument mean center is the little blue dot, really kind of close in Burnett. And you can kind of see that looks about right. And the monument direction, you can kind of see that the Threadgill properties really kind of pull in the direction of that. So the next thing I did was a linear analysis of our points with lines. So what I did was I pulled in a shapefile that had the regional roads in this area. I selected a location of traverse points and monuments that, actually I think I just did the traverse points, that intersected these roads with a 15-foot buffer, meaning, we can pretty easily get to these points. They're on a road. It'll be pretty quick for us. And the next thing I did was a network analysis. So, if you're at one traverse point, a network to see how far or where we are for the next traverse point, and kind of where these monuments are in conjunction with this network. So, for Burnett County and Burnett County roads, because I had two separate files, those are the points that I extracted for Burnett County, and you can kind of see in Burnett County where the black is, that's the traverse points that are on or near a road. Same thing for Llano. You can see I didn't get that many in that county, but the data, I didn't have that much data in Llano either. I was really hoping to have a little bit more for this, but it is what it is. And so for the control network, when I first did it, it just looked like a whole bunch of dots. So I zoomed into Burnett just to give us a kind of idea of the roads, the traverse points, and the monuments, and kind of how this program can give you an idea of, if you were driving, what roads you could take and where the monuments and the traverse points are from this road, which is really kind of cool. If and it can also put in time, but I didn't have any information on our time, so I couldn't input that. So with all this, I think we're going to next do a comparison of the two, and I think kind of make a little bit of ideas of what exactly these patterns mean. What does it all mean? What is it saying about us? So the control. Give you a little chance to read that in. So for the point density, I think it really is telling us that the point density is near Burnett. And for the monuments, the density concentrations, due to the nature of monuments, I think we are going to have, multiple density points, just because for these properties, some of them have many monuments, and it's going to be dense. And it's going to be a little bit more dense than other properties. So for the mean center, the mean center here is southeast of Burnett, and for the monuments, it's northwest of Burnett. I think ideally we would like them to be a little closer to each other because it kind of reflects a more uniform network. Directional mean. So for the control, the directional mean is going northeast, a northeast-southwest direction. And for the monuments, it's a northwest to southeast direction, which they're kind of going the opposite way. And I think ideally, we would like a tighter area, a more similar direction. I think they should all be going one way, all be going the other way, and kind of reflect the same area. So a spatial analysis comparison. When we look at this, I did a monument to control network nearness. What is the statistics from the monument to the control? Well, I had a lot more monuments than I had traverse points. So it really kind of skews the data to make it look as if the monuments are so far from the traverse points. But I think it's mainly because I had way more monuments than I had traverse points. So it kind of skews the data to make it look like they're really far. For the control, and if we look at the control and the monuments, really we're not doing too bad. They're pretty similar. The mean isn't that far from each other. And the density points, of course, they're going to be dense wherever we are monument dense. Subdivisions, whatever, whatnot. So, the point density really doesn't shock me that much. And, all in all, I think it looks pretty good. So I think our goal is, as a company, we want to kind of skew these networks to where our monuments and our traverse points are going to be kind of equal. Not too much equal. I expect, a little bit of lag between the monuments and the control, just because control is going to be inherently smaller than our monuments. But I think, we should strive to get these a little more closer together. And I think with this, we're able to take the points that I've got and we can kind of set them up to improve our control network and to set up a control network where we could use our own scale factor. And we can use this data to go and set up on these points and, we could have our own scale factor, our own network, and I think that'll kind of help us out in the field to be faster, more accurate. We can use these control points whenever we get new jobs, pull it up. We've got control points near this property, near that property. We've got these monuments that should be here because we all know that we've had monuments disappear, so we know they've been there before. So, there's a lot of good that we can come from this analysis of data, and not so much, just looking at this data. We can start seeing more about processes and patterns where we're going. Obviously, with the directional data, we can see we're going one way with our traverse points. Our monuments are going another way. But, for the most part, we're going in an east-west direction. We can kind of see that most of our jobs are in the east-west direction. And, we can kind of build on that. So, I want to tell y'all, thank y'all for letting me use your data and your time. And if y'all have any questions, comments, observations on the data and the processes.
So how do you think we can use our control to maybe integrate with the GIS system? I mean, for like, so we can kind of like bring up a GIS map and know where our control is. Just where the crew can pick on a point, get the values for that point, go out there and do that. How hard is that going to be to do?
It's not going to be that hard. And I think what the most interesting part is that we can also bring those regional roads in and kind of put a relationship between those points and a road, and we can kind of figure out how they're going to get there, how far it is away, what they can use, that kind of thing, and even to the next job, from here to another job. And I think that's a very advantage of using this kind of software.
Mm-hmm. Yeah, because I think that we've talked about this before, but taking our GPS running static some points where our networks, we go ahead and run static on those, get a good fix and get a good solution on those so that we can use those points for setup, because that's like what's getting us out there on the County Road 200.
Right.
We don't have any control out there, and so we're having to do it, basically autonomous and tied to the existing bearings on that, where it'd be nice to be able to put that stuff in our network,
Exactly.
So we know where our jobs are, we know what jobs we've done, and it saves us, a lot of time, so.
Creating master files.
Yeah, I'd like to set some kind of a GIS thing up where we can do that, know where the control is, know where the monuments are. If one's been knocked out, we can remove it from that. We have a lot of LCRS data that we can put in the map. And I don't know if they've got any GIS data that we can attach to it, but we may even check on that.
I don't think they have a lot of stuff attached to it, if any. Just an observation. I noticed that your monumentations are in an elongated ellipse, and your
For the directional.
right, and your control is more is not as and
Right.
it occurs to two things occur to me here. Monuments indicate a large number of monuments in a particular direction, which might indicate where the next influx of settlers, people settling in this area, are coming from. The other thing that might skew that and may cause it to be a little bit different is that you may not set as many monuments in a particular area when you're doing the subdivision, especially with GPS, where your control points can be further apart and maybe not require as many as they would in a conventional setup, where you have to have traverse control points near every corner that you must measure. And so that might be what's skewing this to some degree.
Right. And it's all based on the scale of the data that we've got,
Sure.
the usable data. But I think it's an interesting point. It's kind of, the monuments may kind of tell us the processes and patterns of where people are settling, where we as a survey company are going, and
And where we can concentrate.
Exactly. And I think that's part of the advantage of some of this GIS, the Esri package, is that, not only does it do what the basic stuff that we do, the statistical analysis of it kind of gives us an insight of what this data actually means. And
you can I was just wondering also, we could add, where we're doing a lot of subdivision work, if we took that and showed subdivisions, even if we get some slow times or whatever, that's where we can concentrate our control, where we've historically been doing subdivisions and work like that, because we know we're going to be going back and that stuff. So that may be an idea to put that together, where we can go out there and set some more control.
And it would
static data.
Right. It would also be nice to incorporate a lot of LCRA's existing control into our network so that we are tied in with them, and help improve our accuracy.
Right.
Yeah, because a lot of times we may be able to leapfrog into control, so we may be able to set up some of their control where it's weak, where we got weakness, set a point of our own, run a good long session on it, and then tie into another one of their points, and then we can set up on our point and tie both of them just to check ourselves and know, just to know that we're in good shape.
Well, Marissa, I appreciate this. This gives me a new insight into which direction we're kind of moving as far as a community, if nothing else.
Right.
And I believe this is an excellent use of the GIS ideas,
right,
to show patterns of growth, patterns of
right. And like I said, when I started this, I was really kind of thinking of a control network. It was really kind of something, the idea was really kind of basic. But once I started kind of going through these statistical analysis, it really stuff started popping out. And I think that's the whole point of this class.
it morphed into a different being.
It did. It's really like, yes, you've got these things, but what does it mean? What is the implications of these things? So, and I think that's what makes this software just a little bit above other kind of software, is the statistical analysis that comes with it. And it did kind of say in the book how these statistical analysis is really kind of hard for people to grasp. It's really not that interesting for a lot of people, but
well, I think being able to graph it out like you've done gives you a real good idea of where we need to look at in placing our control and stuff like that. Whereas, sometimes I guess when we just sit here and crunch numbers in the office, you don't really see the patterns. So good job. Good job.
Excellent. Loved it.
great guys.